In video 30, we're going to cover the SCS method, which deals with curve numbers rather than runoff coefficients that the rational method uses. And the curve numbers themselves are responsive to the different soil types A, B, C, and D that occur on the site. These soil types can be downloaded from the federal government website, and we will witness all these here and proceed into the program. Now, we're also going to deal with land covers. We've overlaid over the entire watershed the land cover pasture land, pasture grass rangeland, and if you double click that, you can see that it is responsive over a great range of curve numbers from 39 to 80 to the soil type A, B, C, and D. We have not downloaded these soil types yet, but they will come into play once we do on these land covers. Now, in this area, this is actually a residential half-acre lot type area. So what we're going to do is drag and drop that land cover into that little defined zone there. And let's double click that and review some of their curve numbers. And even in residential land covers, it varies by soil type. Now, the next step in the process is to go to the soil download. So we're going to download the soils from the USDA website, and we'll pause while they're being downloaded. But before we pause, you do need to witness how you proceed. You type or click on Finish Command, and it creates the soil polygons automatically. Now, as they're being downloaded, we'll pause. Let's resume at 98%, and it has now completed the process. When you hover over any portion of the watershed, you can look to the upper right. You can see we're in soil name Lowell, soil group C. Now, D is the most clay-like, A is the most sandy, and this zone here is Eden D, and here is Eden D again, and here is Brashear C. So with these designations, we can actually calculate the peak flow, factoring in the soil types and the land covers that we've defined. And as it calculates, we'll pause. So we resume, and we find that the peak flow in this watershed has been calculated at 32.2 CFS. Now, what size of a culvert might be required here? This is our road. We have our low points within this vast pond. 993.8 over here, it's 993.6. Let's do the following. Let's put in a culvert that starts at this low point, crosses the road, and just heads towards this other low point on the other side to establish an alignment. That reduced the headwater to as shown in yellow. But as a matter of fact, that would produce a 1.59 headwater divided by diameter of pipe result. We happen to know that this has a 36-inch box culvert. It came up with a 30-inch round concrete pipe. Let's switch over to a rectangular pipe of 36 by 36. The way you do that and have control over the size is switch from calc pipe size to calc headwater. Now we can change the pipe rise to 36, and that reduces the headwater. Let's see what it does to the HW divided by D. It's less than 1. A very good design. And in fact, if we review a picture of it, that is what was selected for this road, 36 by 36. Let's head back to the program and just show one more nuance here. Let's go and add a head wall and make it look more realistic. We're going to go to a North Carolina style head wall, looking close to the one that's in place, and drag and drop it on the pipe, on the box culvert, and we've accomplished that. And then what we'll do is go to the outlet and just drive it into the hill. It'll drive all the way to the point where it only has 6 inches of freeboard, and push it right up against the embankment, and do the same for the inlet. And then we'll go and review what the inlet looks like now that we've completed that process. And there it is, looking quite realistic at the base of the embankment, looking very close to the appearance of the in-place pipe box culvert. So that is a final result with a very good reduced headwater, and you can complete the process with these head wall placements, and having pushed them into the hill, you can actually run the storm again and determine the final headwater line. And we'll pause while it runs. And here is our final result: 32 CFS of flow, and the final headwater line shown here.